Hello everyone, in this lecture we will be going over USAMO 1990 problem number 5. Here's a view of this problem and a simple sketch underneath that problem. We're given an acute triangle ABC. Here you can clearly see our triangle ABC on the plane. The circle with diameter AB intersects altitude CC prime and its extension at points M and N. And the circle with diameter AC intersects the altitude BB prime and its extensions at points P and Q. So we would like to show that points M, N, P, and Q lie on a circle. So let's just go ahead and explain what's going on. So obviously we are told that CC prime is an altitude, so this is a 90-degree angle here, and similarly BB prime is an altitude, so that's also 90 degree. So the circle whose diameter is AB will definitely go through that point B prime because of this 90-degree angle which subtends this diameter. In a similar way, the circle whose diameter is AC will go through point C prime because this 90-degree angle here subtends, intercepts this diameter. So far we have kind of an understanding. Obviously the intersection between line BQ, or you would say BP, and CM, this intersection is the orthocenter, I should have said H, so it's the orthocenter H, because these two are altitudes here, CC prime and BB prime are altitudes. So as a result, so this line here, actually this line will have to go through that point. So let's call the foot of our altitude here as A prime. Why would that be? Because the foot of the altitude here, obviously we have a 90-degree angle here on this side. It subtends the diameter. As a result, it must be on this small circle omega 1, and this angle is also 90 degrees, angle AA prime C. As a result, it must lie on the big circle omega 2. Now finally, we would like to show that these 4 points M, N, P, and Q lie on a common circle. Let's use our radical axis theorem again. So let's start by considering the circumcircle of triangle MQN. So consider the circumcircle of MQN. I would like to show that this circumcircle which goes through these 3 points MQN, MQN would in fact go through point P as well. If I can show that the circle, which is obviously 3 points define a circle, that circle would have to go through point P. That's what I want to show. So show that, so I have an equivalent statement here. Show that circumcircle of triangle MQN would go through P, or equivalent, I should have said, P lies on that circumcircle MQN. Why is that? So notice that this red circle, the circumcircle of MQN, let me call it omega 3 here. So the radical axis, of omega 1 and omega 3 is simply line segment MN, or if you will, line CC prime is equal to CC prime. In a similar way, we also know that the radical axis of omega 1 and omega 2, radical axis of omega 1 and omega 2 was simply AA prime, this altitude there. So therefore, the radical axis of these 3 circles, namely omega 1, omega 2, and omega 3, is in fact the intersection of these 2 radical axes. So the radical center, I should say, is the point H in the intersection of CC prime and AA prime, which is actually the orthocenter. So these 2 radical axes, they meet at this radical center. It must be that our circle go through that point P, Why is that? Because the radical axis of omega 2 and omega 3 is in fact equal to that. So you know it must be a line which goes through. So this radical axis is defined as it goes through their common intersection Q. So first of all, and second of all, it also goes through the point H, which is the radical center. So we already know that this red circle goes through Q because that's how we defined it. We are defining the circumcircle of MQN, and I also know it has to go through H, so therefore it is the line, so the radical axis of omega 2 and omega 3 is the line BB prime. But by construction, BB prime intersects the point P, so therefore omega 3 has to go through that point P. So as a result, you can clearly see that Q and P, so that's my radical axis. And so that beautifully proves that the points M, Q, N, and P are concyclic points. So, and that solves our problem.